Okay, sir.
Yes,
Yeah.
sir. It started, sir. Live actually started.
Yeah.
Warm greetings to one and all present here. On behalf of Biomedical Department, Arupadi Vidu Institute of Technology, I take immense pleasure in welcoming our resource person, respected HOD sir, faculty members, my dear students, and all the participants to the webinar on Introduction to Robotics and 3D Printing in Healthcare. Now, I request our HOD sir, Dr. M. Ravindran, to say a few words.
Thank you, Lakshmi ma'am. Good morning to all the participants and a warm welcome to all of you. I welcome our speaker, Mr. Imtiaz Ahmed Khan from Novatech Robo, Bangalore. And on this occasion, on behalf of Biomedical Engineering Department of ABIT, Vinayaka Missions Research Foundation, I would like to convey my sincere thanks and regards to our management who have always been supported us to carry out various programs. And I would also like to honor and give a special thanks to our Chancellor, Dr. A.S. Ganeshan, who has been so nice and supportive to us and faculty members and students to go on with the extracurricular activities and various programs. And as far as our biomedical engineering is concerned, we have been organizing various events, and even in pandemic, we have organized various events recently. And we are actually focusing on various areas and research. And one of the primary area we focus is on 3D printing for healthcare applications. So I understand this workshop was going to give all the participants an outline and insight on this additive manufacturing, which is called as 3D printing, and the robotics in healthcare industry, the support of robotics in healthcare industry. So, like we all know, there have been various robots for healthcare, like we know Da Vinci robot for surgery, and recently so many industries, robotic industries and academic institutes have come up with nursing robots for this pandemic situation. So, I understand this is going to be a thought-provoking session for every participant, and it's going to be a nice, wonderful day for everyone. And as far as this webinar series, we are actually continuously having some interesting topics of webinars. Today we have this robotics and 3D printing on healthcare, and tomorrow we have bio implants, and probably end of this month or next month, first week, we are going to have a international webinar on EEG analysis for disease diagnostics or on neural disorders. So we are actually trying to give as many as technical knowledge to all the participants over the country around India. And I wish all the participants to have a wonderful session ahead and have a wonderful day. And I should thank coordinator of this webinar, Ms. Lakshmi Sri, who has taken enormous effort on this organizing this program. And have a wonderful session ahead. It's over to you, Lakshmi ma'am. Please go ahead.
Thank you so much, sir. Now, in this emerging field of robotics, artificial intelligence, 3D printing in healthcare, it's great pleasure for me in welcoming Mr. Raye Khan, CEO of Novatech Robo, Bangalore. He is a master graduate in science who started Novatech Robo for promotion of robotic education, research, training, development, manufacturing, and promotion in India. They mainly focus on student community in learning more about robotics, and they have trained more than 2,000 engineers, and more than 100 professors are being trained in faculty development program as well. Not only in India, but also students from abroad have benefited their sessions. Hope the session would definitely be a wonderful benefit to you all, and have a wonderful session ahead. Over to you, sir.
Good afternoon. Thank you, Lakshmi. Thank you to the staff members. Welcome to all the participants who are present here. I'm here to explain you what is the importance of robotics in day-to-day life and how medical engineering can work on this field. See, I have been in the field of robotics for the last 11 years. One of the pioneers in India to start robotic training programs. And let me come to the actual position of robotics. What is the meaning of robots. Where do you find these robots? See, all of the people who are present in this audience have used robots in one or the other way. Robots does not mean only humanoids. Anything that automation is working is a robotic system. Over the period when I started robotic training, many of the engineering colleges, many of the college students, everybody, even now also when some of the institutes run robotic competitions and use handheld devices to control the robots. The robot should be an autonomous body which should function autonomously when you program to do some functions. So when you create a robot, what are the requirements for a robot to be autonomous body? The first part in robots is the mechanical structure of a robot. That is a challenging job, and for which mechanical engineers are required. If you want to create a robot, you feel that the simplest measurement is in create a humanoid and fix the components inside it. It is not so simple, because fixing components, the size of the components, the functionality of the components, the strength of the components, all matters. And it is a challenging job for the mechanical engineers who prepare a robot. Then comes the second part of it is the electronic engineers, which controls the movement of the robot and the activities inside the robot to move, to act, and to function any given task. The third part comes with the electronic engineers who design this one. The third part comes to the software engineers who design this functionalities. Which part should move well? What are the functions of this part? And the fourth part comes to the machine learning part, which is a part of this one, programming, where the data has to be put inside the robot. I was I think 4 or 5 years back, students started coming from the medical engineering field to me to learn robotics. One engineering college from Vellore, they had this medical engineering robotics. They were the first to come to me some 6, 7 years back, asking me this one. Then I was wondering what this medical engineering has got to do with robotics. Today, I feel that there is no medical engineering there is no robotics without medical engineering contribution, because all the data has to be contributed by medical professionals for a robot to function. See, where are the robots functioning? See, anything you take it, that is robotics. You take your washing machine, it's a robot, because it functions at intervals. It automatically controls when to function, when to operate. You take your AC, that is also a robot. It controls the air conditioning, the temperature of a room. You take it anything, that is a robotic activity. You take even the car. There are many cars which are working on the robotic technology. See, all these things put together robotics. Robotics does not mean that it is creating a humanoid. Anything that works autonomously is a robot. And today, without robotics, there is no field which can operate. You take it in the agriculture field, there's robotics. You take it in designing, robotics is simple. You take it in automobile industry, robotics is simple. See, let me come to the contribution of robotics in medical engineering. Today, no hospital can work without a medical engineer, because all the equipments that are there in the hospital are autonomous bodies. It has to function 24 hours, and it has to give the information whenever it is required. So creating a robot and designing a robot and making a how it functions and all those things. That is important for a medical student to learn. So where does he start? What is the part he can take in the robotics? And which are the components which he can start with the robotics, whether electronics, mechanical, or the computing part of it, or designing the software. So the field is so big that all the 5 streams of engineering has to contribute for it done. But ultimate functions and designing of a robot to function particular aspect of a medical work has to be done by a medical engineer. Now coming to what is the difference between robotic and humanoid, human operations in medical field? Why robotics is required? Now take the current situation of COVID. See, the body temperature has to be measured when the human has to go inside, touch the human to take the body temperature and other things. Earlier it was the situation. Today you walk through a screen, automatically the robotic device measures your temperature and intimates and informs the authorities what is your temperature. The body scanning can be done without a doctor touching you. The entire process can be measured using this process. Now, if you can do that, always the thought is that whether the robots can replace humans. No, it is not possible to do it. To build a robot also you require a human. And in the case of doctors cannot be replaced by a human, by a robot. A robot only assists the doctor in functioning this one. It makes his functions easy. In a precision operation, there is an always possibility of a human error. Because the movement of a hand can shake at a particular spot, or the precision of a cutting device may change. That is why when robot do the operation, they will have the precision. It will do exactly what has been programmed to do it. And it can do the program continuously. Say, for example, today you have this COVID situation. In this, the temperature has to be measured for the numerous people who are coming. If you keep a doctor to measure the temperature, he may make an error sometime, or he is stressed to such an exhaustion that he may fail to perform his functions. Whereas a humanoid can function this 24 hours a day and 7 days a week. And it can function continuously the same operation. That is why humanoids or robots are important in today's life. Now, building a humanoid or a robot is not that easy task. It is a continuous developmental process, and it requires a lot of technology, a lot of inputs into it. But as an engineer, first you have to learn what is the coordination between different components. And to see how the components work. I'll ask one of my member who is present in this audience, Mr. Subramanian. He will play a video and he'll show you, or I'll try to play one video and show you how the coordination of different components take place in a humanoid, so that you will understand what is this one. So can you play the video? Madam, can you? Hello, Lakshmi, madam.
Sir, yes, sir.
Can you? Okay. Can I share this one?
Yeah, sure, sir.
Yeah. So that they can.
Yes, sir, you can enable it, sir. It is enabled, sir.
Sharing is enabled?
Yes, sir.
Are you able to see the screen, my screen share?
How to explain artificial intelligence to kids. Teaching kids about artificial intelligence and machine
We're not
learning
able to see the screen, sir.
possible.
1
The
minute.
words itself, artificial intelligence and machine learning, sounds
So the
complex.
screen is not visible, sir.
Difficult to learn. How to explain.
Actually, you have to open the application, then you have to give share, and then select this application to be displayed. So that's how it works.
No, it is possible. You are seeing the screen?
Yes, sir. We're
Hi.
able to see.
Artificial intelligence to kids. Teaching kids about artificial intelligence and machine learning is pretty tough, but it is possible. The words itself, artificial intelligence and machine learning, sounds complex, but that they are not difficult to learn through robotics. But kids can understand the artificial intelligence concepts easily through robotics. In the past, we used to have these large machines where people used to key in the information, and the machine goes ahead and processes those instructions. Now, good news is that these machines are gone much more smaller, like laptops, iPads, smartphones, and kids can use these iPads to play games, watch videos, but essentially following your tab instructions, and these machines respond. So human beings were responsible for giving the direction to the machine in the past, but things have changed. Look at this picture. A human can see the bird flying, but it is not pretty easy as simple for a machine to do. This machine, through video, could look at a moving object, in this case a bird, and convert that into some sort of data. These birds have certain features and characteristics based on that the machine would say, hey, based on the data I see, this is a bird. And that is the concept of very high level of artificial intelligence is, learns from data and informs it's a bird. Pretty much like human-like decessioning of intelligence. So briefly describe what artificial intelligence is. Artificial intelligence is the ability for machines to learn, think, and behave like humans. For lower grade students, we can't teach higher end programming, but we can make them understand the concept behind the artificial intelligence through robotics. Do you know what programming is? A computer is a machine, and we can do literally anything we can dream up. And the way you can do this is the process called programming. Basically a set of instructions that we give a computer to do some task. For a lower grade students, we teach Scratch programming. For higher grade students, we train on C, embedded C, Python programming. In this video, the robot moves forward and stops when it sees the edges. Now we relate this robot to human. These color sensors works as human eyes. If they sense or see an edge, it passes the message or information to the human brain, which is the controller. And immediately the brain passes the message to the motors. Which is the legs of humans, and makes the motors to stop, and then moves back and take right or left turn.
Hello. Hello.
Sir, yes, sir.
Can you hear me now?
Yes, sir.
Hello.
Yes, sir, we can hear you, sir.
Yeah, you can hear me. Okay. See, now you have seen the program, how the devices is shown. This how to artificial intelligence works in a human being and the machine learning part of it. See, this is the simplest device we use to teach the small students and even engineering college students in a 6-hour program where they design how the coordination between different components of human take place and how a machine can replicate those process using this one. So this is a simple process where all the equipments are ready-made. Like the brick is readily available, which
It's
process
1
the
o'clock.
human which replicates like a human being. The second part is the motors works like in legs or any part of the human body, and there are different sensors which functions like different. Are you able to hear me?
Yes,
Hello.
sir. We are able to
Oh,
hear, sir.
yes, sir, we are able to hear you, sir.
So this is how the entire process of a human going. And the first part is we make one person to understand how the relationship between different parts works, how the coordination can pass from one this one to one device to another device, like sensors to the controller, controller to the different components which functions based on the controller's command. That is the basic process of learning robotics. Then come to the second part where each component has to be built by the particular persons. The design of the this one, the brick has to be made by a mechanical engineer. The internal components like this one, electronic devices have to be made by an electronic engineer. The computing part of it, then how the coordination takes place, that has to be done by a computer engineer. And then power supply engineer, electrical engineer will supply the different power requirement for different products or different components that is involved in this one. So this is how the process goes. Now, if a device is there in a hospital, if it is having some problem, see, you may not be at this stage able to build all the complex components, but you should be able to do at least check where is the defect happening, where is the problem arising, and how to rectify the problems. These are the components which a medical engineer learns and will understand and coordinate to repair or working of the systems, handle the systems and other things. That is what we teach in the medical engineering part of it. Now, it is not limited to that. It is limited to different components. See, we have, there was Alberg University, Sudan. Uh, an engineer had come to do research in our center 3 years back. Balbalo Stanslow was the person who had come for his doctorate degree thesis to be done in India. He was sponsored by the Sudanese government, government of Sudan. He's from Alberg University, European University, and he's a Russian studying in European University. He came to study here. He came to find out how a drone can be used in a hospital industry. There are two hospitals in Bangalore, Fortis Hospital and Manipal Hospital. The distance between Fortis Hospital and Manipal Hospital is 6 kilometers, 16 kilometers. And due to traffic, Fortis Hospital is in Banakata Road and Manipal Hospital is in Old Airport Road. The traffic between these roads is heavy. And every day, Fortis Hospital did not have a lab to test the blood samples and samples of different this one. And every day, the vehicle has to carry 3 times these samples to the Manipal Hospital. Each time it was taking 2 hours, sometime in the peak hours, to reach that hospital. Plus, there is an involvement of a person who is driving a car. There's a small involvement of a vehicle. There's an involvement of a pollution. All these components were involved in this task. And the time was also a critical issue. Now, he came to learn this drone technology in hospital industry. It was able, we were able to transport the same samples using a drone in 16 minutes to that hospital. What was the expenses? Expenses was almost 20% of what we were using earlier. So there was a saving of 80% in the expenses. There's no involvement of a driver, a person, no pollution. All these things were eliminated. Now, recently, I was in discussion with the same boy who did research at our center. Now he's doing in this one hospital in Sudan. He's working on how to transport different components inside the hospital using a drone. These are big hospitals where they are using drones to transport the components and the medical requirements from one block to another block using a drone. See, you can, as an engineer, you can think of anything and start building. Once you know the concept, once you understand how it works and what are the involvements, you dream. I tell a lot of people the simple thing: you dream and come, we will make your dream true. That is the concepts on which a student should work. He should first learn the basics, then think how I can apply these basics to different usage. See, we were having one, I'm not carrying those photographs and other things, I'll just show you. See, we were in an exhibition in Dubai in the month of February. We had shown, January, we had shown some of the components like transporting of the, food items from one place to another place. The same device now is being used in many of the hospitals in European countries, and even somebody bought it in India also, to ship the materials from one location to supply the food to their patients, because a person cannot reach the patient. Even we had displayed there a small trolley where it can carry the components to different patients, different locations. See, these are the things which a medical engineer can do. And the limit is not, a medical engineer does not mean that he should learn only medical engineering. He can learn anything. Any component, once you decide that you are able to do something, you should be confident enough to start that and do it. And before you starting anything, you should be prepared with the basic. What I showed you, the program, that we teach it for third grade students in international schools. We hold competitions also in the international schools. I am associated with Lawrence Technological University, Michigan, USA. I'm one of the director in RoboFest there. So we conduct a competition. In that competition, for third grade students, these programs, how to do is taught. The same thing I have done it in Christ College for engineering students. In PESET, PS College also we have done. Nitya Meenakshi we have done. We have done it in this one, MS Ramaya College also. We started with teaching them on these important products, to learn first the basic how the operation of the robot takes place. Then we go for them to engineering part to each stream to teach them how each component can be built by them. Unless you start with these process, it will not be possible for you to learn. As I know, only these devices, which is Lego components, which we use for the basic understanding, is done by SRM University in Chennai, which is doing this in a very large scale. And we are doing at different places the same components we are using to teach different students. Now, the second level is learning this program. As we have shown that you can do in C programming, you can do it in Robot C, you can go to still advanced Arduino, you can go to still advanced Python training program, Raspberry Pi. Then you can go to machine learning. All these components and different, each component, each controller has a different programming language. You have to learn this programming language, then only you can build a robot. And for this, we have got all the sources and resources. And we have recently started online training program. So we have entire course curriculum for online training, including robotic process automation, RPI, and also robotic operating system also we have done online training programs. So with experts available with us, we can train all these programs to you online. And whereas students can think of a product, come to us, we will show you how it can be applied. And the same way we train the people in how to do about this process. Now, in today's world, the difficult task for the teachers or the professors is to cope up with the students. Now, unlike earlier days when we studied, today's student, the moment you tell something, he will go and Google in the Google and come back and tell you, start asking hundreds of questions. So a teacher, we conducted a lot of teachers training program in government of Kerala, conducted two locations we have done. In the teachers training program where the faculty members, we taught about what are the things. Unless the faculty members know all these things, they will not be able to cope up with the students. They will not be able to teach the students what. So we have done there. You can, in the hospital industry in India, we are very, very slow and very less. See now, I have one of my friend who is doing hair planting. In this one, he's using traditional hand puncturing and weaving of the hairs. Now there is an automatic device which is available, artists in USA, which can do the entire hair planting job autonomously. And it can do in 4 to 5 hours, which normally a surgeon will take 2 days. And the precision and the accuracy will be good. And then you can take it easily. There's no transmission of any disease or anything, because all these devices can be this one sanitized and can be used from one patient to another patient without any difficulty. And my friend had recently had a legal problem where a patient had some infection in his head because of some, if he wrong with this one, it became a big issue. And you can use these devices for this, but still a doctor is necessary to implement this. Not any ordinary person cannot do this without a professional doctor. One. Number two is your medical engineers have the opportunity in maintaining these machines and making these machines, programming these machines, all these things in medical engineers. So why and where the medical engineering has got the applications, they have tremendous applications. But it has to be properly implemented, properly guided to them. What is the task? And now the training programs in India have been insisting for a long time to make their students, engineering students, to make one compulsory project for them where they can make a commercial robot. See, now we have starting a VWORK program. We have got the syllabus, but we cannot start because of some other reasons. So VWORK in robotics has started. Where what we have done, we have suggested that Global Open University in Nagaland has started this program. We have provided them all the data for engineering syllabus and other things, where each semester, first semester is the teaching, second semester is a live project. They have to make a robot. Not only make the robot, they have to sell this robot into the market. And we have given a simple machines itself, simple concepts, and we give a team. Number of projects are available with us. We give a team that you make this project, go to market and sell this project, and your marks will be decided on how fast you can do it, how you can do it, how your performance will be there. So we have got the videos of different products. We tell them, okay, this is the video, go and show to the market that you can deliver this. Take an order, come to the lab, prepare that model and go and deliver that model. That is the real part of an engineer to do the product and make the. So we have got 4 products in this semester the student has to do. In a course curriculum, they have to make 4 products, different products, from a simple device to the most complex device in the final product. So this is the way in engineering is taught in USA and other places. That is what we want to implement. And we have talked to this one universities, and Niti Aayog has started this program, VWORK program in engineering, where every semester a student has to build a commercially viable project. See, now most of the engineers who pass, the moment they come out of the universities, everybody thinks of this one, starting in this startup venture. As per the information that is, I got it, I have it. 85% of the startups have failed because they dreamed something and they wanted to go and build this one product. They had a lot of failures. Time is a part of the constraint because they were not knowing the basics. They start building the bigger projects. A prototype has to be designed. The one which we showed you in the video, it's a prototype. The same prototype application, you can elaborate it into a bigger device. See, it is the same concept is used in many ways. Like you can use this in the hospital for the movement inside the beds. You can use this in autonomous cars. You can use it in any other purpose for even your home movement and other things. You can use these devices. This is one part of it. See, I was also working with one university in South Korea. We had a project, collaboration project for assistance to aged people. That was one dream project which I was working with them, but due to some reasons I have discontinued. Now I'll be starting once again. That was one big project where the aged population have difficulties with the growing of the fast growing of this economy. See what happens, most of the children are abroad. Their parents and the aged parents are sitting at home. There is nobody to help them or look after them, and they don't have anything to play with. So now that project was, they have already come up with this first level of the program, the South Korean university, and it is already there in the market. And the second part was to be still more advanced, where each parent can work with the humanoid, and the humanoid will detect his body temperature, this one, and it intimates to the kids or the doctors involved, giving them exactly what is the position of this parent. It can even read the brain of this one by seeing his emotional, this one. picture face, how he's feeling emotionally about his attachment to his kids and other things. All those things can be done. These are the different fields available for the medical engineering people to work in robotics. Robotics with medical engineering is this aspect of it. Now, with this, I conclude. If anybody is having any questions, I'm ready to take it. You can come up with questions.
As participants, if you have some questions, you can raise them. Lakshmi, could you please check whether participants have raised any questions in the chat box?
No, sir. I've unmuted them also. There is no questions in the chat box, sir. We'll go ahead, sir.
Oh, fine. Yes, sir. I think as of now, there is no questions from the participant side. I think we can move further, sir.
If you want any time, you can get in touch with me for any programs which you want to have it. So this is the basic brief part of it. If you want to take up any specific task, any specific subject like Python or like machine learning, 3D printing. See, I was not touching about the 3D printing part of it. Now, 3D printing, you have to design a component and make the components print. See, mechanically, the most difficult task in robotics is mechanical designs. And see, I'll tell you one example. Making a humanoid arm, you have to fix the arm with 16 motors, which has to be implanted at different locations. So these motors size and the weight and the strength all has to be coordinated, and that is one challenging aspect, because if you want to fix a motor on the arm which can lift 10 kgs of the weight, if it can lift 1 kg of the weight, there's a lot of difference. Difference in three factors. One is the size of the motor, the weight of the motor, and third, the power of the motor. What is the power consumption of the motor? Once you increase the power consumption of the motor, you have to increase the power availability at the bottom level, that is the battery. The size of the battery. So these are the challenging aspects. The coordination between different components is important. And if you have a bigger size motor, it will not fit into the arm. You have to make the size of the motor as per the size of the arm, and it should fit inside. And these are the challenging aspects. And for this, we have a different program where the mechanical part, how the mechanical students can learn. Mechanical part, making a 3D printing, how the design of the 3D printing can be done. We have 3D printers. We are the cheapest 3D printers. We don't go by the precision, because precision 3D printers will cost more. It can go up to, see, high-end 3D printers can go up to $1 million. $1 million is a 3D printer which can manufacture human cells. Have been used to 3D print in heart or a lung part, which is the research has been done. Some of the works have been already done where the 3D printing is done. Can you go directly to print a lung without learning with the basic components? Because their failure is $1 million failure. You have to first learn in a artificial, this kind of small and 3D printers, how to print a lung using a plastic material, which costs you only, the printer is cost you around 20,000. The entire product will come out to you within 100 or 200, 300 rupees. But when you go for a printer for a human heart or human lung, using tissue cultures and tissue which has been used for culture robotics. So that will cost you very huge. So that is why we want all the students to start learning 3D printing in this. We have 3D printing programs also. See, now online training programs, what we are doing is we will supply to this college or this one the equipment on a higher basis. The students can purchase the take the instruments, either purchase them or take it on hire, and the college will take the responsibility of returning back the equipment to us with the charges. So they can, we can deliver these equipments to the college. The college can run the program. We can online show you, like what I'm giving the presentation, my engineers will show you how to build the program, how to run the program, how to program this one. And the program is of 10 hours, 10 days program, each day 1 hour session with it. But you will have the resources available for you in our LMS system. All the resources, how to build the program, how to program the component, everything is available online. So you can learn that. After that 10 days program, you can return the equipment along with the charges. That is the way we are. If you want 3D printers, we can supply the 3D printers to you. A person can install it. A person can do how to installation, everything will show. You can run the 3D printers. After doing the 3D printer, you can return the 3D printers. We will charge you on an hourly basis, on a daily basis for the 3D printer high charges, plus the training program, we can do it on. So we have done this successfully in UAE, Dubai. So we can do it. We are now planning to launch this in India also. So we are starting this with our this one. So anybody who wants to learn in 3D printing or Arduino or basic humanoids or basic Lego components, all this they can do it. The entire program is available on the website. You can see which program which you want to take. There are professionals who are available anytime. You can take an appointment with the professional and take. See, daily there will be a 1 hour session with the professors in group of any number of students can take it. 1 to 100 also can take it. So each student, if they want, we can supply the kit. Because this COVID situation where lockdown is there, you cannot do it from the college or something. We can supply directly the equipments to the students. The students can take the equipments, pay the high charges, and run the program. And see, after that, they can return the equipment. Or if the students want to buy the equipment, they are also available at a very concessional rate with us. They can buy the equipment. Our trainers will train you. You can learn from the home itself. So now you don't have to waste your time in doing this as a vacation period. See, all the students, the biggest issue for the students have been learning theoretically. Now we are giving the options of learning them. Practical lab can be set up at your home yourself and learn through our process without spending a lot of money in this. Okay. Anybody interested, you can get in touch us. We will give that details. Okay.
Sir, can we have a demo of the working or any robotic scheme, sir?
Okay, you can have it if you want. Now itself on the demo, I can ask one of the, can you shift the training? Subbu, I'll just give me 1 minute. You can open one person by name Subramaniam is there in the audience.
Okay, sir.
He can give you a demo itself. He is now in Dubai, so he can get it connected. He can show you how a program can be built and done. He just open his mic. I'll talk to him and get him set up for you. Now it's up.
Okay, sir.
Actually, ma'am, please unmute the person so that we'll have a discussion with him also.
Yes, sir. Yes, sir.
Good afternoon, one and all.
Subbu.
Sir, good afternoon, sir.
Good afternoon. Can you give a building instructions or any of the programs which you can show it online to them?
Sure, sir. I will show Lego as well as Arduino also. Just give 1-2 minute time, sir.
Okay. You can start.
Sir, I had joined in mobile. I'm joining from laptop. Just 1 second, sir.
Okay.
I'm logging through laptop, sir. Just 1 second.
Get this one. You can put one video also into that.
Yes, sir. That's what I play the video also.
Building videos. Building programming videos.
Yeah, yes, sir.
Ma'am Lakshmi, ma'am, can you just check whether sharing option has been enabled for this bit display? Lakshmi, ma'am.
You have mechanical also in your, this one, medical engineering section.
So biomedical engineering is an individual department. We also have a mechanical department in our
No,
college.
but in medical engineering syllabus, you don't have anything connected with electronics, mechanical, and computer.
Yes, sir. We have a syllabus related to electronics and mechanical also.
Okay.
So students it's like interdisciplinary field, so that they'll be having exposure to all the domains, like electronics and mechanical, as well as electrical also. So it is like a mixture of
They
the
can pick
combined
up the
department.
basic part of it, so that
Yes,
that is an essential part of the training program.
yes.
You are from which stream, sir?
So I'm from biomedical engineering, sir.
Biomedical.
Basically, I'm an electronics background, so I work under biomedical engineering department.
But biomedical engineering, as such, might have come in the last 8 or 10 years, only, no?
Yes, sir. Yes, sir. So it is actually an
Earlier,
emerging field. We could see a lot of scope in near future.
Yeah,
Because,
that is, I you know, there's a way, see, robotics itself has got a huge scope, and biomedical engineering is important because there are a lot of devices. See, maybe 5, 6 years back, when I was talking to some this one, some minister, medical engineer, medical health minister. He was telling that thousands of lakhs of material is lying in the hospitals which cannot be used because they cannot be repaired, because they are not. See, these equipments, most of the equipments are imported, and they could not repair these equipment because of lack of technical people who have got some knowledge about how to utilize it. See, a medical engineering person who has got some knowledge about the subject, so we can start these activities so that it can become operational. See, any device which is used in medicine has to be connected with the engineering. So that engineering portion is what you are now, I think, concentrating on, medical engineering field.
yes, sir. It is full of automation, and because in upcoming medical sectors, so everything will be automated, obviously.
Yes.
So we actually find a lot of demand for especially biomedical engineers in future, so that they have an knowledge on both in biology as well as in engineering stream, so that they'll be able to design systems for the diagnosis and treatments, just to make the patients to feel more safe and comfortable for their treatments.
Now, I
So,
am also from the field of science, biology.
nice. Fine, sir.
I'm also
Nice.
I'm a master in the MSc in agricultural biology.
Fine, sir.
And for the last 10 years, I've become more concentrated towards robotics. But we are
No, I think we are not able to hear you, sir. Sir, I guess you have muted your mic.
yeah. No, it was somebody else had muted my this one. I was not.
Oh, okay.
Okay. So this is one field we have done for even engineering, agriculture colleges also we are doing.
Okay.
Hello.
Ma'am Lakshmi, ma'am, can you able to check whether the screen sharing is enabled for the person who is going to show the video now?
So can you see the screen?
Yes, sir. We can see your screen, sir.
This is, as Sir told, Legos for prototypes, which can be easily built and showed for the students to learn. Here, one of the example, I will show you the video. I'll play you the video.
Yes, sir.
So these videos are for higher grade students with Scratch programming. They do even train for engineering students, like as Sir told, C, embedded C, Python and all. I'll show one of the video, teaser video. It's a simulator.
Yes.
Just 1 second, sir.
Yes.
This is one of the medical projects. 1 second, sir. This is a GSM-based automatic paralysis patient healthcare system video, sir.